When you look up at the night sky, what do you wonder about? What do you think about? I think many of us now, and maybe for human beings going back as long as we've been human beings, we often wonder what else is out there, like up there, out there in the universe. Is there life beyond Earth? I think is a question we often ask ourselves. And human beings have also wondered a long time, is there life on other planets? The other planets that we see in our own sky that we now know are part of our solar system, or anywhere else in the universe. And I think we probably began just by looking at one place we have a pretty good view of, even without modern technology of any kind, and that's the moon. And here's a little more modern view of it, but people have been looking at the moon and wondering about it and using it to time the length of a year and a season, and speculated that maybe there's life up there, maybe there's other beings up there, maybe there's something up there. And we've since gone there and looked around, and there doesn't appear to be life. We were actually worried about it when we first went. Maybe there's some microbes or viruses or some sort of contagion that would come back to Earth. But in fact, there wasn't. And there was also no atmosphere of note, no liquid water. We now know that there's some frozen water and water combined with other elements there. But it didn't look like, we now know, a place where we might find life. And so we started to look at some other places. And naturally we turned to the planets of our own solar system, one of which, of course, is Mars. And a lot of speculation about Mars. As soon as telescopes became better, the features of Mars, beyond it being just sort of a slightly red glowing star-like point of light, we found that it has features. We've now been there, we have better telescopes, we know that these features are geologic and climatically produced. And maybe there's life there, but it doesn't seem to be any Martians as intelligent life or large life forms that are inhabiting the planet Mars. But we do have spacecraft there now and robots there now, and we are exploring Mars today. And I think there's a good chance we might find some form of life, because we found water there, and we found other things that might make life possible. Although it's cold, and there is a lot of challenging conditions for life as we know it, life that we model, that we think of as thriving life on Earth, would have difficulty on Mars. And so there's another place we've been thinking about. And the other planets don't look so good as harboring, places we're going to find life. Jupiter, an example, a gas giant planet. We have sort of a small rocky planet, as Mars is, and Venus and Mercury. And Jupiter, the largest planet by mass in the solar system, is it doesn't really have a solid surface. It might have a solid core, and it's possible that there's some form of life that we don't really conceive of, don't know the mechanism of how that form of life would work, could live there, but it doesn't seem likely. However, we actually have been to Jupiter now, and we've been to the moons of Jupiter, and several of them are sort of interesting. Here's one called Europa. And Europa does have liquid water on it. How much, we're not sure, but it appears to have a liquid ocean underneath a surface of ice. And where there's liquid water, we think there's a good chance of finding at least the chemical conditions that drive life on Earth. So perhaps we don't have to look just for planets. We can look at planetary bodies like a moon that is in the right place, but is actually not a planet itself. But then we start to look at things further away. And, what about planets that aren't in our solar system, that are sort of part of another solar system? And we can look at one here. This is a planet that's been discovered. This is an artist, rendering of it based on the science of what we know that it probably looks like in terms of the gases. I'll let it up a little better for you, that are on it. We know that this particular planet is the right distance from its sun to have liquid water on it, and it appears to have water, and it would be liquid on this particular planet because it's in what we call the Goldilocks zone, not too hot, not too cold. So possibly a habitable zone for life, because we really do think that most life chemistry needs liquid water to do the processes of life. So what's an exoplanet? Well, it's a planet that is X, or out of our solar system. It's around another star. And they were hypothetical really all the way until 1995. I mean, people thought they would probably existed. We didn't know how many there would be in our galaxy, how common they were around stars. There was hints of them earlier than 1995, but 1995, not that long ago, is the first time we actually saw enough data, enough evidence through multiple measures that said there's a planet around a star. The star is out towards Pegasus if you look in the sky tonight. And it has mass and it's orbiting its star. And since then, we've discovered a lot of stars. A lot of stars with planets. And that's pretty challenging because they don't make much light of their own. They're very small. But let's take a look at what we found so far, and I'll tell you a little bit about how we found it. So each one of the bright points in here is actually not a star, but a star-like shine of a planet, of confirmed planets that we have found either through telescopes on Earth or telescopes that we've put into space telescopes. And what we found out was there are a lot of exoplanets. In fact, even as lately as the 1990s, the idea we thought was that there was probably about 20% of planets of stars had planets. We now think that almost all stars at some point in their life cycle actually has some planets on it, and most of them seem to have more than one. This is a view of our galaxy. It's not a photographic galaxy. It's based on a similar galaxy, and all the points of light here are points of discovered exoplanets that are confirmed. There's over 5,000 planets that have been discovered. And if we look at this from different angles, let's see if I can get that to show. There is one, I'll make it a little bigger. There's one beam there's some stars that spread all around, or these points of light that represent planets. There's this whitish draw here, which was a particular instrument. In fact, it's the TESS instrument looking towards the center of the galaxy. And then even more planets, exoplanets, discovered by Kepler. And this is a view of Kepler saw, this bright field here. And it looked in a very narrow band, a narrow part of the sky. And it's found thousands of stars where it looked. We just haven't really looked carefully in all these other places. These other planets, exoplanets, were discovered by more general surveys, but Kepler really is the sort of champion of exoplanet finding. And there are, in fact, over 5,000 of these points of light that represent discovered and confirmed exoplanets. And we confirm them by multiple measures. We find them maybe by one way, and then we actually keep going until we can confirm them by multiple types of sensors. And it's not easy. Typically, we find them through indirect measures at first, things like the dimming of a parent star as the planet passes between us and that star as it orbits the sun. And then to confirm it, we have to wait till it orbits again. So for instance, if we're looking at Earth, it would take a whole year to see it again. So we have to keep looking a long time. And there are some stars that have planets that orbit much faster than that. And we also have some other means of finding them that have to do with the spectrum, what's called the Doppler shift in the light that we're seeing, so we know that the planet is moving away or towards us. We can also see sometimes wobbles in the parent star, the star at the center of a solar system or star system of its own, that's being dragged about by the gravity interactions with its own planets. But let's take a quick look at the main missions. How do we know? Let's look at TESS. TESS is sort of easy to remember, I think, because TESS is based upon, it's an acronym, and the acronym stands for the method at which it detects stars, which is a transit exoplanet survey satellite. And you're looking at TESS right here. And we'll leave the little searchlight on it. And its instruments look to see whether it can look at those little slight dimming of a planet as it crosses in the path and blocks the light between Earth and the planet and the star behind it. And it's a very successful tool, and it is been, I can probably show you, I think, a little bit about where we've seen it. Well, let's look here. So all of these dots are stars. The different colors represent which type of planet they are. We can talk about that in a moment. But this strange field here, these little squares, this is where the space telescope Kepler looked, and it looked in a very narrow range out through the disk of the galaxy, out kind of sideways, not towards the center, but across it. And it found almost everywhere it looked, it found exoplanets. TESS, I might be able to find TESS's field. There's Earth. If I do this right, let's just put, there it is. So there's what TESS found. There are the white colored points of light, which are exoplanets that TESS found. And TESS found a lot. But as you can see, the field that Kepler found is really amazing. And we've also seen planets from Earth-bound telescopes, and even one of the most famous telescopes is, and that would be Hubble, which you probably recognize here. And Hubble is able to image both in visible light and in other wavelengths, and has been used especially to reconfirm what other space telescopes have seen, so that we know that we have for sure an exoplanet. And incredibly, we now know that there are more exoplanets in our galaxy than there are stars. So does every star have planets? It seems like most of them do. And some of them have many, and some of them only a few. And we've done enough of a survey, and here's a picture of that survey, that we're getting a fair sense of what the population of planets looks like in our galaxy.